a thermodynamics system and the control volume. A thermodynamic system dynamic system is a device or combination of devices containing a quantity of matter that is being studied. To define these more precisely, a control volume is chosen. This is a system. Is chosen so that it contains the matter and devices inside a control surface. Everything external to the control volume is the surrounding. So we have a definition also with the separation provided by the control surface. By the control surface. So we have a system, control volume, and the surrounding, and also control surface. The surface may be open or closed. To mass flow. and it may have flows of energy in terms of heat transfer or work flow of energy in terms of work or heat or work. The boundaries may be movable or stationary. In the case of control surface that is close to mass flow, so no mass can escape or enter the control value, it is called the control mass. In the case of closed control surface, no mass can escape or enter the control value. The system called control mass. Control mass selecting the gas in the cylinder. The control mass was shown in the picture here. Selecting the gas as a control volume. These dashed lines show the control volume. By placing a control surface around it, as shown, system boundary, control surface, we recognize that is a control mass because the system is closed system control mass. If a Bunsen burner is placed under the cylinder, the temperature of the gas will increase and the piston will rise. As the piston rises, the boundary of the control mass moves. As we will see later, heat and work cross the boundary of the control mass during this process. What matters that the composite the control mass can always be defined and remain the same. An isolated system is one that is not influenced in any way by the surrounding. This means that no mass, heat or work cross the boundaries of the system. In many cases, A thermodynamic analysis must be made to a device such as an air compressor, which has a flow of mass into, in, out of it, or both, as shown schematically in this picture. We have another control system example. So we have an isolated system is one that is not influenced in any way by the surrounding. This means that no mass heat or work cross the boundary of the system. In many cases, a thermodynamics analysis must be made of a device such as an air compressor, as shown in this picture here, whose flow of mass into it or out of it, or both, as shown schematically. The procedure follows in such an analysis is to specify a control volume that surround the device under consideration. The surface of this control volume is the control surface, which may be crossed by mass, momentum, as well as heat and work. So this is we have an isolated system here, and also a device control volume device. For example, a compressor A, we have low pressure. In this case, let me change the location. No. The device control value with the mass, heat and work crossed by. Crossed the boundaries. This is an example and device control value. Thus, the more general control surface, the surface of this control volume is the control surface, which may be crossed by the mass, momentum, as well as heat or work. Thus, the more general control surface defines a control volume where mass may follow in or out with a control mass out. The special case of no mass flow in or out. Hence, the control mass, so we can write to be a general control surface define a control volume. Where mass may follow in or out. With a control mass as the special case of special case of control volume with closed boundaries. On mass flow. The difference in the formulation of the analysis is considered in detail in Chapter 6. The term closed system, fixed mass, and open system involving a mass flow are sometimes used to take this distinction. Here we use term system as a more general and loose description for a mass device or combination of devices that then is more precisely defined when a control volume is selected. The procedure that will be followed in presenting the first and second law of thermodynamics is first to present these laws for a control mass and then to extend them to analysis to the more general control value. Macroscopic versus microscopic point is the next subsection, the next video part.